This is going to be Chapter 2 quiz. So keep in mind that each quiz will have different problems because each problem is pooled, but it's possible that you would get some of the same questions on your quiz, but some of them will be different. And it's also possible that you would get all different questions. But I thought this was just a good way to review some of the ideas in Chapter 2. So if you have questions, you can listen to my explanation of these 10 examples. And then if you still have questions, or if I didn't cover something that maybe you want to know about, you can drop in office hours, or you can send me an email. Okay, so number 1, use the Venn diagram to list the set A union B in roster form. So you can see that this is a multiple choice question. So we have A, B, C, or D. We want A union B, and we want roster form, meaning we want a set with curly brackets, and list all the variables or all the letters that are in that set. All right, so A union B. Remember that means or, that's a union. So it's anything that's in A or anything that's in B. So I'm going to color in circle A. So you can see that by coloring in circle A, I would be including the letters A, C, V, X, B, and M. All of those letters are in circle A. Circle B, I'm going to color that one in blue. So when I color that one in, you'll see that we include the letters M, F, G, B, T, D, and S. So all of those letters are in circle B. Notice the M and the B are in both circle A and B. So if we wanted to know the intersection, remember the intersection means and, what's in A and B, or what's in common to the two, that would be just the M and the B. So the and, the intersection, means what's in both sets. Whereas the or, which is what it's asking in this problem, is what's in either set. If it's in either set, it counts. So we need to have, let's start highlighting the letters. Clearly, choice A is not going to be enough. Choice C is not going to be enough. So B and D have the most letters in it. And if I'm looking at part B, see how it has a Y included? The Y is out here. That's not included in the set, so that's not going to be it. So the correct answer is D. So A, B, C, D, A, B, C, D, F, G. So I'm just verifying that all the letters are here. M, S, T, V, X. All right, so I've underlined every letter, so it's all included. So that one is the correct answer. All right, number 2. For sets U, remember U is the universe, A and B, construct a Venn diagram and place the elements in the proper regions. Okay, so here it tells you what's in the universe, what's in set A, and what's in set B. So it doesn't tell you what's in set A and B, but you will know that if they have anything in common. So let's look and see. A is in B, but not in A. B is in B, but not in A. E is in both A and B. And F is in both A and B. So E and F should be the part in the middle, right here. See how this is in that middle section? That's in the circle A and B. None of the other middle sections have the E and the F in the middle. So this has to be the correct answer. So we will know just from that part right there. But let's just verify and make sure everything else is in the correct spot. So that means that C and D should be in A, and G. C, D, and G. C, D, and G should be in A, but not in B. And then we have A and B should be in B. Perfect. And then let's see, A, B, C, D, E, F, G. There's an H. So there's an H that's not in A or B, but it's in the universe. So it's out here. So that makes sense. It matches up with all the information given. But sometimes just getting one piece of information, like that piece of information in the beginning that E and F are in A and B, that gave us the answer right there. But if you want to just make sure and double check your work, you can just verify all the other pieces make sense as well. All right, number 3. Use the Venn diagram to determine the roster form of set A and B and C. Or you could say A intersect B intersect C. So remember, this is what's in common with all 3 sets. So we want to know which numbers are in all 3 of the sets. Remember that the intersection of 3 sets is this middle part right here. So that is a member of set A, right? Because it's all of this circle. So that's a member of set A. It's also a member of set B because it's within this circle, right? And it's also a member of set C because it's in this circle. So that one part in the middle is part of all 3 of the sets. So 9 and 11 are the 2 numbers that are in the intersection of A and B and C. So 9, 11 is what you would put in the set brackets, okay? And that's it. That's the answer. That's what they're looking for. Number 4, decide if the given statement is true or false. If it is false, give the reason. So this says that black is a subset or a proper subset of brown, black, and blue. Okay, so black is a proper subset of the set brown, black, and blue. So remember, to be a proper subset, each element in the first set must be in the second set, but it also cannot be the exact same set. So the first set must be smaller or contain less elements than the second set in order for it to be a proper subset. Remember that this is subset. When you take that line off the bottom, that makes it a proper subset, right? And then it also talks about an element, but remember, element looks like the E, right? That means it's an element of, okay? So black is contained in the second set. The first set is smaller than the second set, and the first set doesn't have anything that the second set doesn't. So this is actually a true statement. So we would choose choice B. This statement is true. So just to kind of recap here, remember again that you should take this quiz as many times as you can because you'll see different problems each time you take it. And so you should be familiar with not just the words that you see in your quiz if you only take it once, but you should be responsible for all of the words. So you should know the difference between a subset, a proper subset, an element. So all of these ideas you should know that are tied to the ideas within the quiz. All right, number 5. 30 cities were researched to determine whether they had a professional sports team, a symphony, or a children's museum. So right there, I'm going to stop. I'm going to notice that I'm talking about 3 things. Okay, so right there, looking at that information, I'm automatically thinking, okay, I'm going to need to make a Venn diagram with 3 circles. They're probably going to be asking me about that. Of these cities, 17 had a professional sports team, 16 had a symphony, 13 had a children's museum, 12 had a professional sports team and a symphony, 8 had a professional sports team and a children's museum, 8 had a symphony and a children's museum, and 6 had all 3 activities. Complete parts A through E below. Okay, so before I can complete that, I really want to make a Venn diagram. So I'm going to use the space above number 5. All right, so let's see. I'm going to have, this is going to be the sports team. And then I have the symphony. And obviously these are not very good circles, but, you know, close enough. Okay, and then I've got the Children's Museum. Okay, so you can see now, hopefully, anything that's going to be in the green circle is going to be in the sports. Anything that's in the red circle is going to be in the symphony, and anything in the blue circle is going to be the museum. So I'm going to put the numbers where appropriate. In this case, it gives you for each thing, for the pairs and for the triple. In this case, if it tells you, so this is what you're looking for first. If it gives you how many had all three, you always want to start in the innermost part, like the triple intersection, and then work your way out. That is the easiest. If they don't give you that information, you're going to have to piece it together, and it's a little bit more difficult or challenging. But this one, they give you that, so that's nice. So 6 had all three. So I'm going to start in the very middle part. Remember that represents the intersection of all three things. So 6 goes there. All right, next I have the doubles. That's what you want to look at next. So 8 had a symphony and a children's museum. So a symphony and a children's museum, that's going to be the intersection of the blue and the red. So this whole part right here that I just highlighted in yellow is going to be a total of 8. Do you see that we already have 6 in the middle? So we already have 6 right here. So that is going to only leave 2 to go right here because that total has to add up to 8. So if you know the total is 8 and 6 is in the middle, then 2 would be what's left over for that part. All right, so I'm going to erase all those marks and just put the 2. Okay, so now we want to look at the next double. So now it says 8 had a professional sports team and a children's museum. So 8 had a professional sports team and a children's museum. So that is going to be the intersection of the green and the blue. So this is also 8. Again, we have 6 in the middle, so that only leaves 2 to be put right here. Whoops. 2, okay? And then we are given information about another double. So it says 12 had a professional sports team and a symphony. So sports team and a symphony is this shape right here. That total has to be 12. If there's already 6 there, that leaves 6 to be put in the other part. So 6 would go here. All right, now we're going to look at the single circles. So we have the Children's Museum. So 13 had a children's museum. That means the entire circle that's blue has to add up to be 13. Now notice it doesn't say 13 only had a children's museum, because if it said only, then that would be, let's see, that would be this part. But it doesn't say only, it says had a children's museum. That means the whole circle has to add up to 13. So if I add the 2 plus the 6 plus the 2, I would get 10. The total has to be 13. So 13 minus 10 is 3. Okay, so now we're going to do the same thing with the symphony. So it says 16 had a symphony. So this whole symphony circle has to add up, all the pieces have to add up to be 16. So we have 6 plus 6 is 12, plus 2 is 14. So it means it only leaves 2 to be in this part of the circle. So all of those numbers within that red circle add up to 16. And then finally, we have 17 had a professional sports team. So we want this entire circle in the green to add up to 17. So if we add up the numbers that are in there, we have 6 plus 6 is 12, plus another 2 is 14. 17 minus 14 is 3. let's see if I can get that. There we go. And so that would leave 3 for that part of the circle. Okay, so if you have any questions about how to fill in the circle with the information given, you can send me an email or you can watch this again and try on your own, but it's important that you're able to fill in a Venn diagram. So let's try to answer the questions now with that drawn. Okay, how many of the cities surveyed had only a professional sports team? So only the professional sports team is going to indicate you just want the part here in the sports circle, but the part that's not in any other circle. So that answer would be 3. Okay, how many of the cities surveyed had a professional sports team and a symphony, but not a children's museum? So let's start. So let me undo that highlighting. Okay, so we said this is 3. Let's start by highlighting this part. So it says professional sports team and a symphony. So sports and a symphony would be all the numbers in here. Okay. Then it says though, but not a children's museum. So we want to take out the part that is in the children's museum as well. That would be that bottom 6. So that means now we're only looking at this number. So 6 have a sports team and a symphony, but not a children's museum. So that answer would be 6. All right. Part C. How many of the cities surveyed had a professional sports team or a symphony? Or is the key word here. That means it could be in the green circle for sports, or it could be in the red circle for symphony, and that would count. So the green circle, the sports, there's everything in green, or the symphony. So that would be the answer when we add up all those numbers. So that would be 9 plus 8, 17, plus 4 is 21. So that means there would be 21 cities that have both a professional sports, or not both, sorry, that's wrong, right? Not both. They have a professional sports team or a symphony. They have one or the other or both. Okay, part D. How many of the cities surveyed had a professional sports team or a symphony, but not a children's museum? Okay, so the first part, the professional sports team or a symphony, is what we started with in the last problem. Oops. So that's everything that's in the green or the red. Now it's saying, but not a children's museum. So we need to erase everything that's in the blue circle. So now the only thing that is included here is the 3, the 6, and the 2 that are still shaded in yellow, because that's sports or symphony, but not in the blue, right? It's not the children's museum. So that answer then would be 11. Okay, the last one, part E. How many of the cities surveyed had exactly 2 of the activities? All right, so let's see if we can erase the yellow. I guess we could not do that here. Nope. All right. Okay, so how many of the cities surveyed had exactly 2 of the activities? So let's look at what that means. Remember the numbers out here that I'm highlighting now? Those are all the cities that have exactly 1 activity, right? The 3 would be the sports, symphony would be 2, and museum would be 3. Okay, the ones that have exactly 3 are the ones in the very middle. So that would be 6. The ones that have exactly 2 live in these parts. So 6, 2, and 2. All of those numbers are in the parts that have exactly 2 activities. So we'd add those numbers up and we would get 10. So there are a lot of questions that we could ask given this information. And so it's really important that you know how to set up the Venn diagrams and also how to, answer a lot of different questions. How to determine the ands and the ors and what has exactly 2 or exactly 1 or both but not a third. Something like that. All right. Number 6. A coffee shop collected the following information regarding purchases from 120 of its customers. 57 purchased coffee, 38 purchased donuts, 16 purchased coffee and donuts. Okay, so notice we're only comparing 2 things this time. So this is a little bit of an easier setup because we're only comparing 2 things instead of 3. So I'm going to make my Venn diagram right here. I'll make the red be the coffee, and then the blue be donuts. And of course, whatever is in that middle football shape is going to be the intersection, or the people who bought coffee and donuts. So you always start with the middle parts if they give you that, the intersection. So it says 16 purchased coffee and donuts. So we're going to go ahead and put that number in first. And then it says 57 purchased coffee. So the total of the red circle has to be 57. So 57 minus the 16 that are already in that red circle would give us 41. So if I add 41 and 16, that's giving me that total of 57. All right, and then it said 38 purchased donuts. So again, everything in the blue circle has to total 38. So 38 minus 16 is 22. When I add 16 and 22, I get that 38, which is how many purchased donuts. Now we want to complete parts A through C. So of those surveyed, how many purchased only coffee? So the only makes a big difference, right? If it says how many purchased coffee, that would be the 57 that they gave us in the beginning. But since it says only coffee, they want the 41. Okay. Of those surveyed, how many purchased only donuts? Again, that word, that's the 22. And then last, of those surveyed, how many did not purchase either of these items? So in my Venn diagram, I failed to draw the universe. I should have drawn the universe, right? So here's the universe of people that were customers, right? So this is the universe. It said they had a total of 120 customers. So let's add up the 41, the 16, and the 22. That's 79. So they had a total of 120 customers. We can do 120 minus 79, and that'll give us 40. Oh, not 49, 41. Okay, so that means 41 people entered the coffee shop and bought something, but they bought something other than coffee or donut. They bought something else. Maybe they bought a tea or a cookie or whatever. So how many did not purchase either of these items? That would be 41. All right. Number 7, use the Venn diagram shown to list the set C in roster form. Okay, so here we're just looking for set C. So you identify the circle C, and then just look for everything that's within that circle. So that would be 11, 12, 13, 14, and 17. So, whoops. So 11, 12, 13, 14, 17. I can't fit it all in there, so I'm just going to add it like that. All right. Number 8. Draw a Venn diagram that illustrates the situation described. B is a proper subset of A. Okay, that means that B is going to live within A. Everything that's in B is also in A, but A is a larger set containing more items than B. So that would be choice C, right? B is completely living within A. That's what it means to be a proper subset. Number 9, we have these sets U, A, B, and C, and they want us to determine A intersect C. So remember, the one that looks like the upside down U, or it looks kind of like an N, means intersect. That means and. That means what's in common. So we're looking for what is in common between sets A and C. So let's look and see if there is anything. So in set A, there's an A. In set C, there's also an A. So that's something that they have in common. There's D in set A, but there's not a D in set C. There's an E and an E. So that's something else they have in common. There's an F in set A, but not in set C. There's an H in set A, but not in set C. There's a J and a J. Okay, so what they have in common is A, E, and J. So that is the intersection. So that is answer A, E, and J. You would choose choice B, the set is empty, if they have nothing in common. All right, the last one, number 10, use the Venn diagram to list the set of elements in roster form. So remember this little, looks like an apostrophe, that's a complement. So this means A complement intersect B complement. That means what is not in A and what is also not in B. Okay, so let's think about that. Okay, so first let's look at A complement. That means everything that's not in A. Okay, so it means everything that's not in the blue circle, okay, is going to be in A complement. So I'm going to go ahead and list those things out. That's P, Y, Z, F, J, D, V. Okay, so all of that is in A complement. Okay, now my goal is to see where that intersects B complement. Okay? So I'm going to now look at B complement. So I'm going to erase the red. And now I'm going to look at B complement. So what's not in B? So I want to see what is in the universe that's not in the pink colored circle, set B. Okay, so you can see it's all of those things, right? It's everything in the set A and the universe. So I'm going to list those elements. P, Y, Z, E, Q, O, and I. All right. Now, I figured out what's in A complement. I've figured out what's in B complement. I've listed those out in roster form. Now I want to find the intersection. So now all I'm going to do is look for what's in common. P, Y, Z, and then that's it. That's all they have in common, right? So that would be the answer. Let's see, that is answer choice B. So sometimes on these, I think it's easier if you list them in roster form and do each part separately, so you can see, especially with the intersection, because it's what's in common, you can see what they have in common by listing out every element. So that would be my suggestion for this one. Okay, remember, if you have any questions about any of this or any other problems that you've seen in Chapter 2, to stop by my office hours this week. We can work on some problems together. I can share my screen, or you can share your screen. We can work on homework, whatever we need to do. So just let me know if you have questions, and I hope you have a great day.